And we are going to pick up where we left off. It looks like we're about halfway through part 4, number 4. So we are ready to do some logarithm equations here. So we're on practice test 1, number 4, E. When you, okay, let's put our quiz out of our mind. I'm glad it's got you all thinking. But what we need to do now is look at the equation E and figure out what we're going to do with it. Now,
You can only do
no. Listen to me. This is important.
add the logs together.
You cannot cancel until you have log equals log. Do I have log equals log? No.
Add a log.
So before you can cancel, you're gonna have to combine these into one logarithm. And then you're still not gonna be able to cancel because you don't have one on that side, so we'll have to deal with that differently. But even like in this problem where you got them on both sides, you cannot cancel them. Right, here's what's gonna happen on test day. Somebody's gonna cancel them. I'm gonna take my pen, I'm gonna put a big huge X and I'm gonna write, ah! And there's gonna be no partial credit. Because you cannot cancel the logarithms until you have log equals log. Now that is never gonna happen in this problem because you don't have any logarithm over here. But you do need to combine these. So how do they go together? A division. When you put them together, guys, they're gonna go together as either an multiplication or a division. That's how they're gonna go together every time. Well, since that's a subtraction, I'm gonna put it together as a division. Now, there are two scenarios. Log equals log, in which case I'll drop the logs, or log equals number. What do I do when log equals a number? Loop-de-loop. So I start with my base, 2 to the second equals x plus 1 over x. What's 3 to the second? 3 to the second isn't 1/3. What's 3 to the second? 9. 3 to the second power means 3 times 3, so 9 equals x plus 1 over x. Multiply the x, so we have 9x equal to x plus 1. And then subtract the x, we have all the x's on the same side, and divide by 8. So your answer is 1 over 8. So we put our logarithms together into one, loop-de-loop, and then did our algebra to solve the equation. Okay? Now, this guy you're going to approach very similarly, well, exactly, in the beginning. See these right here? Can't have it. Can't have it. So how are we going to put those together into one logarithm?
Division.
That's going to be another division. 3x minus 2 over x. It's always first over second when you put them together. Now over here we loop-de-loop because we had log equals number. What do we do when we have log equals log?
Cancel.
Get rid of them. So 3x minus 2 over x equals x. Now we have to solve that.
Multiply.
Multiply by x, just like this one, only this one we multiplied by the x and got a 9x. This time we're gonna multiply by x and get x squared. Put your thinking cap on. What are you gonna do?
Square root.
No, we don't wanna be square rooting, cause then we're gonna have a real huge mess, right? Look at that equation, Sandra. Yeah, and add 2, because our objective is to get the thing equal to 0. Isn't this a quadratic equation? X squared? And we always want to get our quadratics equal to 0. So that we then can do what?
Factor.
Either factor or
Quadratic.
quadratic formula, whatever you want to do. I think that one factors pretty easily, doesn't it?
Yeah.
What is it?
Minus 2, minus 1.
Minus 2 minus 1. You can always use the quadratic formula. It's gonna take longer, but you can always do it. And what will x end up equaling then? X is gonna equal 1 or 2, yep. So we have 2 answers to that problem. They're both fine. So that one we have, if we had an answer blank, we'd have 2 answers in it. Okay? All right, that was F. Okay, so now we have G and H. All right, let's look at G. Any idea about how to do G? Okay, Declan's back there. He's been absent for forever, and he's back there going like this, because don't we have log equal a number? This is a logarithm. The base is e, and when we have log equals a number, we loop-de-loop. So here we go. E to the negative first equals x. Start with the base. E to the negative first equals x. What do I do with negative exponents? I don't like
Right.
them.
1 over e to the
1
first.
over e to the first. So x is just gonna equal 1 over e to the first, or 1 over e. Negative exponents mean 1 over, right? Anytime we have a logarithm equal to a number, we're gonna loop-de-loop. Okay, what about this guy? Now remember, this is a no calculator problem. So anything that's no calculator has to be sort of rigged. Are 27 and 9 special in any way? They're both, what did you say, Scout?
Square roots, they have.
Well, they're not square roots, but I think I know what you
Or
mean.
cubed.
They're both powers of 3. Isn't 27 3 cubed? And 9 is 3 squared. So the way we want to think about it is, if it's a no calculator problem, we want to look at those 2 numbers and we want to ask ourselves, can they be rewritten as some power of the same number? So another example would be 4 and 8. If those were our 2 numbers, because 4 is 2 squared and 8 is 2 cubed. If it's a no calculator problem, you will be able to do that. Okay? All right. So now what? Now that we made them both powers of 3,
3 cancels.
we get rid of these just like we got rid of the logarithms. When we have 3 equals 3, get rid of them, and we can say 3x equals 2, so x equals 2/3. You can't do that unless these 2 numbers are the same. So your goal is to make these 2 numbers the same.
Will you take off if you didn't do the problem exactly that way?
How did you do it?
Like, just like if you like did guesswork, like I just like did the square root of 27 and then 3 and 2.
Okay, but the square root of 27 is wrong.
Well, excuse me, the cubed root of 27, and then you
Squared it?
did the 2. Yeah.
That's fine, that's fine. You gotta have some kind of work down there, and it has to be correct work, okay? So if you had that, that would be correct. You were just logicking it out instead of doing it step by step, that's fine. All right, last one on this page. What are you gonna do with this one?
Live to live action.
Isn't it log equals a number? Whenever it's log equals a number, we're going to loop-de-loop. Start with the base, x to the second equals 9. Now this one, Scout, we will square root, so x equals 3. All right, a couple more without our calculator, then we'll get our calculator out. Write as a single logarithm. So this is kind of what you did with your equations when you smush things together. We want to write this as one logarithm. So we're going to have log of something. So what does that tell me I'm going to have? That's going to be a division. And there's going to be an n on the bottom. What's going to go on the top? Be careful.
M to the fourth.
M to the fourth. Because a coefficient is an exponent. And since it's only with the m part, it only goes with the m. If this had been a plus sign, then I would have the log of n to the fourth times n. That's the only way you're gonna put them together, guys. They're either gonna go together with a times or a divide. That's it. Exponents are coefficients. They flip-flop back and forth here. Are you all right with that one?
Yep.
Because now you're going to do the same thing backwards. So this one is already put together. It's one logarithm. And you're gonna break it apart to have a log of x and a log of y part. It's gonna be broken apart into two parts.
3 log x minus 2 log y.
So what did you say?
3 log x minus 2 log y.
What do the rest of you think about that? Okay, why is it a minus? Because this was a divide, and when you pull it apart, you're gonna pull it apart as a plus or a minus. Since it's a divide, it's a minus. These guys are exponents, so where do they go? Out in front of their logarithm. We had a hard time in our homework, some of us did, with those problems. So you might wanna, take a second look at those and a little bit down here, but is that all right with everybody?
Yep.
Okay, so remember, at this point now, you will turn in your white test papers, and I will give you a pink one or a blue one or a green one or some colored piece of paper. And that colored piece of paper then is your clue that, oh, I'm gonna use a calculator. Your semester exam will be the same way. You'll have a white part and you'll have a colored part, and they are distinctly separate. Okay, so now here we got our colored page. We're gonna get out our calculator and we're gonna do log base 7 of 19. There's a couple different thoughts I have about this problem. What's your thought? Loop-de-loo. She says, look, it's log equals something, so I'm gonna loop-de-loo it. Now, when I loop-de-loo it, I get a problem that looks a lot like that one we had a minute ago. But the difference is what? There's no relationship between 7 and 19. So that's why I need a calculator for this problem. So what do? What'd you say? 7 to the x?
Would you do logs? To get the exponent in front of the log?
7, you can type 7 to the x on your calculator, but you can't get a number. I don't know how you would get that to equal 19. No, I'm gonna do what Scout said. I'm gonna take the logarithm of both sides. This is for what in the world are you taking the logarithm of both sides? Because now this guy comes out in front. And now I can type it into my calculator as log 19 over log 7. And the directions say 1,000. How many decimal places is 1,000?
4.
1,000?
3.
1,000?
3.
What place is this?
10, 100, 1,000.
There it is, right there. So how many decimal places?
3.
3. There's 3 zeros in 1,000. Okay, so that would be 1.513. Now, we kind of did this the long way, which is absolutely perfect. It's fine. You may not remember, one day we had a bunch of these in our notes, and you remember me saying it's always the log of this number divided by the log of this number? The top number divided by the bottom number? So you could go straight to here if you did one of those roller steps. Of course, if you don't remember that rule, it's called the change of base formula, then you gotta go through all these steps. All right, here we go. Rashad, would you sit up and open your eyes, honey? Thank you. Step 1.
Divide by 5.
Divide by 5. So 8 to the x either equals 12 over 5, if you want to leave it that way, or 2.4, if you want to use it as a decimal, doesn't matter. Now, I want you to look carefully at something. Over here, before I did this long stuff, I had 7 to the x equals 19. Doesn't this look like about exactly the same thing? So what am I gonna do? Log both sides.
X log 8.
This comes out in front. So how will I get my answer? What will I type into my calculator? Log 2.4 over log 8.
0.42.
And I got 0.421. Everybody good with that? All right, C looks very similar. What are we gonna do first in C? Please don't panic, because it has an E in it, that actually makes it easier.
We're gonna divide by negative.
We're gonna divide by -2. So would you agree that I have E to the 3.8x equal to 6?
Yes. You're gonna do
And then ln.
Now,
ln.
I've been logging both sides, and I could absolutely log both sides here. But it's easier if I ln,
That's log 8.
because this will go away. And I have 3.8x equal to ln 6.
Divide by 3.
So x is gonna equal ln 6 over 3.8. Let's make sure we all type that in correctly. Don't forget to close your parentheses after the 6. I got 0.472. Anybody else? Okay, we good? Everybody keeping up? What's your test look like? This, so this is what we need to be able to do at the end of next week. We got 2 more practice tests to do, and then we'll have a test. All right, so here we go with our word problems. My formulas are still there. So we'll use those formulas. So let's read number A and decide what formula we're going to use.
Second one.
Non-group.
I heard somebody say the second one, somebody say non-pert, somebody said the long one. Are we all settled on this is the one? All right, so I'm gonna write it down. And then I'm gonna remind myself what everything stands for. End, beginning, decimal interest rate, how many times I'm compounding a year, and time. Okay? So what do I know?
Everything except for time.
I know everything except for time. So what's my A?
10,000.
10,000. What's my P?
6543.
6543. Now, guys, we're plugging and chugging here. We're just plugging numbers in for the letters, okay? So this is gonna look just like that. It's just gonna have numbers instead of letters. What's my interest rate?
0.01875.
0.01875. What's my N?
365.
365. And my T is what I am looking for. Am I going to need logarithms to solve this problem?
Yes.
Yes. Because why?
Because t is an exponent.
T is an exponent. The variable I'm solving for, the thing I'm looking for, is an exponent. If the thing I'm looking for is here, no logarithms. Here, no logarithms. In here, no logarithms. But if it's up there, I need logarithms. Yep, if it's up there. Okay, so what are we gonna do first? We don't log first, we do something else first.
Divide by
We divide.
6543.
So we have 1,000 or 10,000 over 6543 equals 1 plus 0.01875 over 365 to the 365t. Now can I logarithm? Yeah,
Yes.
I can take the logarithm of both sides now, so I'll just stick a log here and a log here. You could, if you wanted to, ln, but there's no benefit to it, because since there's no e in the problem, nothing's going to cancel. But if you want to ln, it works just the same as log. There's just no good thing about it this time. Now, here's the deal, kids. Please don't be afraid of the numbers. This problem is a mess. If you absolutely can't handle it without typing this stuff in and rounding off, then you need to do that, but I will take points off for round up error. Okay? So I prefer you didn't, but if you absolutely can't deal with that, because it's a mess, no question, I agree. But you've got a calculator, I think we can do it. What is our objective? What are we trying to do? Find that, right? Don't we want t equals? So big picture, without freaking out, is this a number? Can I type that in on my calculator and get some number? Yes. Now I'm trying to get t by itself. So what do I have to do with that 365?
Divide.
Divide it over, right? So let's just do that right now. let's take the log of 10,000 divided by 6543 and divide that by 365. Okay, it's okay, it's gonna be bad. And that's what I mean, this is a horrible problem, it's gonna be bad, don't worry about it. So we divided out the 365, so we brought him over here, right? And we did that. So now what else has to be divided over here? Don't we need to divide by this? We're trying to get t by itself. We need to get rid of this number, and since that's a multiply, we're gonna divide. So just hit divided by, don't retype anything in, don't worry about the e, just divided by log 1 plus 0.01875 divided by 365, close parentheses, equals. Tell me what you got for t.
22.
Yep, you did it. See, you did it. 22.624 years. So again, we took the logarithm of both sides so that we could pull this off and make it a coefficient. Now everything's on the same level. No more exponents, in other words. In order to get t by itself, we have to get rid of this number, so we divided by it. And we have to get rid of this number, so we divided by it. It is ugly looking, but it's basic math. Basic math. Whew. All right, let's look at B. What formula are we doing with letter B? Same one. What am I looking for this time? Where will my variable be this time? A? Now I heard somebody say P. Remember, P is the beginning amount. And didn't they tell me I invested $125? So that's my beginning amount, your investment. We call it your principal. That's why it's P, principal. What's my interest rate? 0.03125. What's my N? 12 monthly. And the number of years is 50. Now I'm not going to need logarithms. I've got my whole exponent, so 12 times 50 is 600. I'm gonna go ahead and do that. Here's what I'm solving for. This is like getting t by itself, only I don't need to get it by itself, it already is. So
Just plug it in.
plug it in. 125 parentheses 1 plus 0.03125 divided by 12 close parentheses raised, remember raised to the 600. I got $595.13. Even though the directions say to round to the thousandth, if it's a money problem, I mean, if your answer is dollars, you're gonna round to the nearest cent, right? Don't put another digit on here, that doesn't make sense. How are we? Good? Fine? Perfect? One more. What formula do we need for C?
PERT.
PERT. And we know we need PERT because there's no money involved. Somebody said earlier, we're using PERT because we never use PERT for money. We use PERT for money if we are compounding continuously. Okay, so don't think that PERT can't be used for money. It can, but only if it says compounding continuously. All right, so what do I know here? Everything except what? There's always one thing I don't know.
T.
I don't know T. Oh boy. That means I'm going to eventually need logarithms, right? Because look where T is. T is an exponent. All right, so what do I know? I start out with how many? 1,300 and end up with 3,100. My growth constant is 0.101. Here is a potential thing of confusion. This time I used the actual number they gave me. I used 0.101 because it's not a percent, right? I only change them if they're a percent. This one is already a decimal, so I'm gonna leave it alone. All right, step one.
Divide by 13.
Divide by 1,300. Now, if you want, and I'm not trying to confuse you, but can't we cancel out those zeros? You don't have to, but you can. So we have 31/13.
LN, both sides.
Now, you could do exactly what I did earlier. You could LOG both sides. It'll work out fine. But it'll be a whole lot easier if we LN both sides. Since this problem has an E, because those will cancel. And we, bless you, LN 31/13 equal to 0.101T.
Divide by 0.1.
Yeah, guys, this is just like before. It just isn't as ugly. We need to divide by 0.101. So ln 31 divided by 13, or leave the zeros in if you want, divided by 0.101. I got t to equal 8.604 years. I'm gonna assume it's years. I gotta do a better job, sorry. It's day, it's sometime, right? Hours, days, something. All right, would you agree with that?
Yep.
Okay, all right. So now what I wanna do is, before we start that next one, I do wanna look at your 3.5 homework or 3.4 homework, let me see. Which one? That we did a bad job on. 3.4 homework. I wanna look at that real quick and just make sure that we are okay with this. We did pretty well, as I recall, on the top part. I want to do 1B because it just looks a little more complicated. And then we really need to look at number 2 because that's where everything fell apart for some of you. This is a 3-parter, and your job is to write it as a single logarithm. Okay, this is 3.4 homework, problem 1B. So you should have gotten it back if you did it. Now, inside of here, would you agree there are going to be some things multiplied and some things divided?
Mm-hmm.
But before I start messing with that, what happens to this 3 right here?
It becomes a.
He becomes an exponent. So that really isn't a 2, that's really a 2 to the 3rd, which is 8. So this is the log base 6 of 8. Same thing here, this is an exponent. Now, he's a fractional exponent, which means he is a radical. Since he's a 1/2, that means he's a square root. So this is going to be the log base 6 of 4, square root of 16. minus the log base 6 of q. Now I'm gonna put it together. Because these two are being added, when I put them together, I will multiply. So 8 times 4 is 32. But since that one's being subtracted, I'll divide. And there's your answer. The 6 threw some of you off. What if these, instead of these being 6s, what if they'd have been 5s? Would anything have changed in the whole problem? Nope, nope. Some of you have pointed out, it doesn't matter what the base is as long as they're all the same, right? They gotta all be the same, but that doesn't impact how you do the problem. All right. Let's take a quick look at A and B. You see if we have time. So let's look at A and B real quick. So 2 log base x of p over q. And you are expanding this. So you're gonna have a log of p and a log of q. You're gonna break it apart, 2 logarithms. They're gonna be added or subtracted? Subtracted. What's that do? That becomes an exponent, and since it's out in front of the whole logarithm, that is gonna go with the p and the q.
3, 4.
There's your answer. Okay, some of you butchered these. Let's see, you seem to be getting it now, I hope. Let's do 2b. I'll shut up soon, I promise. Okay. Now this is supposed to be pulled apart, so I'm gonna end up with a log of p and a log of q. That's what I'm gonna end up with. It's gonna be an addition because these are multiplied. There's gonna be a 2 in front of the q. What about this though? What happens with him? Oh no,
It's just x
doesn't
minus
he
negative
go with both of them? So doesn't that mean I'm gonna have a -3 out in front of this? And a -6 out in front of this because it's a -3 and a 2? And there's your answer to that one.
This is for 3, 4?
Huh?
This is for 3, 4?
Yep, 3, 4. Oh, shoot, I'm looking at
Yeah,
the
I was
wrong
gonna say,
homework.
Yeah, I was
Oh,
I
no
was
wonder you're all like staring at me. I'm looking at homework for another class, yeah. All right, I will do one of these. Which one would you like me to do? And then I'll be quiet since I just totally messed up. Okay, so, I mean, they're good practice. It just didn't match up at all with what you had in front of you. Sorry about that. So in 3, 4, I'll either do a part 1 or a part 2. Which one do you want me to do?
Do 2C.
2C is one that we're breaking apart. All right, I have too many different classes going on here at one time. All right, so I'm gonna break that apart. It's gonna involve a 4, a x, and a y. There are 3 parts to this, and they all have to be pulled apart. So you're gonna have a log of 4, a log of an x, and a log of a y. Now, pluses or minuses?
The first 2 are pluses.
This is gonna be a positive because I'm multiplying those, and this one's gonna be a minus, right? What happens to that 3 right there? Goes in front of only the x. So he goes right here. And what happens to the 7? It goes in front of the y. So that would be the correct answer. Now, some of you, and I don't know if this is because you photo mathed it, or you have a tutor, or you looked up, so I don't know. But some of you said, well, but 4 is 2 squared. So this is really 2 log base 6 of 2. Yeah, I'm not gonna expect you to do that on your own. It's true, but I'm not gonna expect it. This is fine right here. Okay? All right. You got a couple more minutes, so if you haven't finished your homework, you can do that.
At least we went along with